Hi friends, good afternoon. After a long time we are meeting. So in fact, I thought I should begin or continue from the place where I stopped, that is differential equations onwards. But now I decided, as the academic year began just a few months back or 1 month back, let me begin with the portion connected with the +1, that is 11th standard mathematics CBSE, the first chapter onwards. So my explanations will be based on the CBSE related portion only. So I thought it will be beneficial to all those who are attending their regular mathematics classes in their schools. And this will act as a revision plus a kind of reference. So let me start with the set theory, which is the first chapter in the 11th standard mathematics textbook of CBSE. Yeah, let us see. First, define the set. Before we define the set, let us see. I have a group of apples. All these apples are belonging to, let us say, one particular station called Shimla. I have got another group of apples which belong to a place called Kashmir. So there are two different varieties of apples I brought from two stations, one from Kashmir, one from Shimla. So now if I want to combine these two apples, I can say that this is a set of apples. This is a set of apples, but both the apples belong to different localities, different places. So now if I define set of apples from Shimla, set of apples from Kashmir, both may have different characteristics. One may be little sour, another may be little sweeter or color wise different. So depending upon the what you call size or color or the characteristics, you can identify which apple belongs to which station. So any apple, if I bring, let us say, from outside and then start trying to put it in one of these sets, you will say, sir, this apple doesn't look like that of Shimla's, or this apple is not matching to that of the Kashmir. So how did you know? Because now we identified separately two sets. One set we are calling as set of apple from Kashmir, another one from Shimla. So third category, if I bring from outside, you can easily compare that yes, this apple doesn't belong to or belongs to. Maybe characteristics after study, yes, this can go and fit in there. So in what way this definitions helped for us? We have formed a set with a particular characteristic. So if I want to bring from any other, from outside any other apple and try to fit in one of this, I must satisfy the criteria of the already formed group. Then only I can put this apple inside. So set theory will help us to define characteristic of the elements present in the set or in the group. Suppose if you define set of people whose height is 6 feet, then all the persons whose height exactly 6 feet will form in that set. Even if a person 5 feet 11 inches cannot fit in that. So set theory is now try to understand that it is nothing but forming or forming a group of certain things or people or anything with a characteristic set of integers. If you define all the numbers which are either positive or negative can fit in this. On the other hand, if you define set of positive integers, it will be only positive numbers. Like from -1, -2, -3, all these numbers 0, 1, 2, 3, anything can come in that set. If you define, let us say 1.5 and bring this 1.5 into set of integers, definitely set will reject it. Set will say, no, this number doesn't belong to me. Because you defined integer, integers cannot have a rational number again. 1 is called maybe an integer, but 0.5 we are telling 1.5. So 1.5 comes under the fraction. We will call rational number. 1.5 means 15 by 10 or 5 by 2. Sorry, 15 by 10 means 3 by 2. Correct? So grouping, if you form like this, the characteristic of the group will decide the characteristic of the incoming numbers, incoming quantities, whether they fit in or not fit in. If you define set of, let us say, complex numbers, example, then all complex numbers will get fit in that. So friends, set theory speaks about the grouping of quantities or numbers with a characteristic. We should understand that characteristic, then only we can form. We can define the nature. It is very useful. Set theory will help us to relate. You can form relations. In a set, you can form relations. You can form functions. You will come to know all these things in the coming chapters. Basically, Venn diagrams will form a very important concept in the set theory. That also will come to know after this. So let us first understand by going to the whiteboard. Let me first go to the whiteboard. There we'll explain very clearly what is meant by set builder form, then what is meant by roster form, these things. So let me first define for you what is meant by the roster or set builder. So now let us say we are now going to start set theory. Okay. What is meant by now set? Collection of objects. Simply we can write here set is a collection of objects. But we have put one rule. What is the rule? Rule is these objects must have a characteristic. Objects must have a characteristic. So if you say set of natural numbers, set of natural numbers. So it will be defined as, let us say, n. N is equal to, you write 1, 2, 3, it will go ending, correct? So now if you want to bring a number called as, let us say, -5. -5 doesn't belong to set n. So therefore, if you want to put this -5 in the n, it cannot be matched. You started with 1, 2, 3, set of natural numbers. On the other hand, if you say set of integers, so the integers set, it is called Z. It starts from -infinity. Here you can go last number infinity, -infinity, dot, 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 -3, -2, -1, 0, 1, 2, 3, infinity. So -infinity to +infinity will form your set of integers. In this, you can bring any number. Suppose 2, if you want to check here, 2 belongs to Z. You consider 0, 0 belongs to Z. But in the top n, 0 does not belong. Followed. So when you are defining the set, you must see clearly what is the definition given. Once the definition is known, you can guess the next number. See, for example, 1, 2, 3, if you write here, what is the next number? Since the difference between the consecutive numbers is only 1, the next number after 3 could be 4. Next 5, next 6, like that. So if you put a rule, for example, only set of natural even numbers, then you know automatically they begin from 2, 4, 6, like that. If you say odd numbers, 1, 3, 5, less than 100. Less than 100 means up to 99, you can go ahead. 100 is not included. Followed or not? So when I am defining a set, for example, if I write n is equal to 1, 2, 3 like this, This entire thing, whatever way I am writing here, is having a definition, is having a one statement. This is called as roster form. The above way of representing or representation is called as roster. So 1, 2, 3, 4, 5 like that if you write, it's roster form. Whereas another way of writing is there. Set of all x. If I write x and one slash, it should be read as set of all x such that this line is called, inclined line is called as like backs. Yeah, this straight line I'm talking about. This is called as backspace, not backspace, sorry. This is called as such that x belongs to n. Close it. What does it mean? You did not write in this way, but anybody who reads this, he will also understand that this set belongs to natural numbers and they begin from 1 to 3. You can write, let us say, set of rational numbers. All rational numbers will come here. 1.1 is also a rational number, remember. 1.1, 1.2, like that you can go ahead to infinity. Rational numbers, if you remember, what is a rational number? Which is having the form of p by q. Okay, in which p should be small, q should be more. That is called improper. Proper fraction will come into picture. So here 1.1, 1.2, they're all fractions. 12 by 10, 11 by 10, like that. You can convert them into proper fractions and then put decimals like this. Similarly, you can write down, let us say I. I is called set of positive integers. They can become 0, 1, 2, 3, 4, etc. up to infinity. These are all set of positive integers. Set of negative integers, you can write -1, -2, like this. Okay. This 0 you can include. Sometimes they will put it in Z. Doesn't matter. You can write 0 also here. 0 is also a rational number. 0 by 1 is called 0. No problem. These are all positive integers. These are all negative integers. Followed or not. So this type of writing numbers with a rule defined is called as the set builder form. Like, for example, n is equal to set of all x such that x belongs to n, like that I wrote here. Then that means this above statement, the above way of representation is known as set builder form. So in the set builder form, we don't write numbers. We give a rule. You go ahead with the rule. So now you can define, if they say that x belongs to n, then you can write on 1, 2, 3, 4, 5, 6. Suppose if I say set of all x such that x belongs to n and x is less than or equal to 5. If I write like this, what does it mean? I must choose the numbers from natural numbers, but I should write only up to 5. This line is equal to line is given. Therefore, I should write only up to 5. Suppose if this is equal to is not there, like for example, set of all x such that x belongs to n and x less than 5. See the difference between this and the top. Here, your numbers will become 1, 2, 3, 4. Okay. So this is the way of representing because less than 5. 0 cannot be included in the set of natural numbers. I think you are aware in the lower classes. So the next thing is called, we are having, next page will go. So here, let us say I am having a set. In this set, 1, 2 I have written. This set I'll call, let us say, A. There are only 2 numbers inside the set. So here, number of elements of set A is represented as n of A. You should write n of A is equal to 2. If you write A is equal to 1, then NA is equal to 1. Suppose if you write A without writing any number, NA is called null set. Null set. A is called null set. A is called null set. If you write without any elements present, sometimes it is called empty set. So A is called as null set. A is also called as empty set. So number of elements, I think you understood now. By seeing this, by now you might have understood that a set will be represented in flower brackets. You can write like this. A representation by like this. Brackets. These are called flower brackets. Followed or not? So next we have to know very clearly, comma we should put whenever you are writing inside the set any elements, 1, 2, 3. If you write commas, we should put. We should not write 123 together. Should put commas. Next thing, we should important point for us to know is, suppose you are having 1, 1, 2, 2, 3, 3. As though it is appearing here 1, 2, 3, 4, 5, 6, nearly 6 elements like that we are seeing. But strictly speaking, it is called 1, 2, 3 only. So elements repeated in the set can be truncated to only once, like that time NA will become 3. Should not write 6. If they are repeating, they are not repeating, we should count and put. If they are not repeating, in this case, only 3. So repeated elements can be scored off to one element only. 1 is repeated here twice, like that. So friends, this is my first class, and I will continue in the next class with some more information so that we will complete the set theory with clear cut understanding how to represent a set, what are the definitions of the set. There are some definitions are there. Afterwards, how to identify elements if they ask us to identify by giving set builder form, and we can put them clearly. Then understanding the open and closed brackets and interval, these are all there. Step by step, one by one, we are progressing, we'll progress. And then definitely by end of this chapter, you will be able to know the set theory very clearly. Thank you all. Any doubts are there, you can put it in the columns.